Hi friends, welcome to the channel. In this video, we'll learn about TCP congestion control. First, what is the meaning of TCP? TCP stands for Transmission Control Protocol. It is a connection-oriented transport layer protocol whose main job is to enable application programs as well as communicating devices, the networking devices, to transfer information, exchange information with one another. So TCP mainly makes use of a concept called as sliding window that is used for flow control. Flow control means that when the sender is receiving data, the receiver is not overwhelmed with too much of data. So when it is overwhelmed, the receiver must be able to inform the sender that it has to slow down the rate of transmission. So for that, it makes use of a concept called as sliding window. And this sliding window has two important features. One is the TCP sliding windows are byte oriented. And the second one is this TCP sliding window size is nothing but the minimum of two things. The actual window size of the TCP sliding window is a minimum of the receiver window size and the congestion window size. So the receiver window size is nothing but the window size advertised by the receiver, and congestion window size is the window size which is determined based on the congestion in the network. So now let's learn about what is the meaning of sliding window, TCP sliding window. So here you can see the picture of the TCP sliding window. The actual bytes which are inside the sliding window, you can see the left wall and then you can see the right wall of the sliding window. And the actual bytes which are inside the sliding window are the bytes which can be sent without worrying about acknowledgement. So you have the left wall and then you have the right wall, and you have three important terminologies here. One is shrinking the sliding window. Shrinking the sliding window means moving this right wall to the left. This means this is generally not recommended, but because it means revoking the eligibility of some bytes. Already the bytes inside the sliding window are the bytes which are eligible for sending. But if you are moving the right wall to the left, it means you are going to revoke the eligibility of some bytes for sending. The next one is opening the window. Okay, opening the window means moving the right wall to the right. This means some more bytes have become, you are going to allow some more bytes as eligible for sending. And the third one is closing the window. Closing the window means moving the left wall to the right. This means some bytes have been acknowledged and you don't have to worry about them anymore. Now let's move on to TCP's policy for congestion control. TCP employs congestion control based on three different phases. Okay, the first one is slow start phase, second one is congestion avoidance phase, and the third one is congestion detection phase. What happens in the slow start phases? TCP generally starts with a congestion window size of one maximum segment size. It starts with a very slow value for the congestion, very small value for the congestion window, and then the size of the congestion window increases exponentially, and that is called as the slow start phase. The second one is congestion avoidance phase. So the slow start phase continues until it reaches a value of threshold, and once the threshold value is reached, it enters the congestion avoidance phase where the data rate is reduced compared to the slow start phase. And the third one is the congestion detection phase, wherein once the congestion is detected, sender will go back to the slow start phase or the congestion avoidance phase, and that is called the congestion detection phase. Now let's examine each of these phases in detail. So this is the first phase, the slow start or the exponential phase. Here, the size of the congestion window, CWND stands for the congestion window. The size of the congestion window starts with one maximum segment size. Okay, this means one segment can be sent. So here one segment has been sent and one acknowledgement has been sent by the receiver for the same. So once an acknowledgement has been received, one round is completed. One round is nothing but an acknowledgement of the whole window of segments is called as a round. Okay, so in slow start phase, after round one, the size of the congestion window becomes equal to 2 power 1. That is, it increases exponentially. 2 power 1, which is nothing but 2, which means two segments can now be sent in round 2. So in round 2, segment 2 and segment 3, two segments are being sent and acknowledgements are also sent by the receiver for the same. Acknowledgement 3 and acknowledgement 4 is being sent for segment 2 and segment 3. Now at the end of round 2, congestion window size becomes 2 power 2, which is nothing but 4. which means 4 segments can now be sent now by the sender. So now it sends segment 4, segment 5, segment 6, and segment 7. And for segment 4, acknowledgement 5 is sent. For segment 5, acknowledgement 6 is sent. For segment 6, acknowledgement 7. For segment 7, acknowledgement 8 is sent. So at the end of round 3, size of the congestion window becomes equal to 2 power 3, which is nothing but 8, which means now 8 segments can be sent. So this is called as the slow start or the exponential increase phase. The size of the congestion window in the slow start phase increases exponentially until it reaches a value of threshold. And usually the value of the slow start threshold is generally 65,535 bytes. Now, once that value of slow start threshold has been reached, then the TCP congestion control algorithm moves on to the congestion avoidance phase, and that is also called as the additive increase phase. So in this case, the size of the congestion window starts with 1. Okay, so 1 segment is sent and then 1 acknowledgement is being received. After 1 round is completed, the whole window of segments is acknowledged, then 1 round is completed. Then in the next round, the size of the congestion window is just increased by 1. Okay, initially it was size of the congestion window was 1. After 1 round, size of the congestion window is increased by 1. So 1 plus 1 is equal to 2. So now 2 segments can be sent. So that means in round 2, segment 2 and segment 3 are being sent, and acknowledgement 3 and acknowledgement 4 is being sent for the same. So now round 2 is completed. So in additive increase phase, congestion window size is just increased by 1. So congestion window size is 2 plus 1 is equal to 3. Now 3 segments can be sent. So it sends segment 4, segment 5, and segment 6 during round 3 and receives the acknowledgements, acknowledgement 4, acknowledgement 5, acknowledgement 6, and acknowledgement 7. At the end of round 3, congestion window size becomes 3 plus 1 is equal to 4. So in this way, the size of the congestion window just gets increased by 1 after every round. This is called as congestion avoidance or the additive increase phase. Now, during the congestion avoidance phase, the size of the congestion window keeps on increasing additively until the congestion is detected. Now, how do we detect this congestion? How does the sender know that the congestion has occurred? In case when we get into a situation where the sender has to retransmit the segments, then the sender understands that a congestion would have occurred. Okay, so retransmission generally occurs in 2 cases. One is there will be a timeout timer. When the timer times out, it's going to retransmit the segments. The second case is when 3 duplicate acknowledgements are received, it's going to assume that a segment is missed or lost and it's going to retransmit the segment. We'll see later why it is going to wait for 3 duplicate acknowledgements. Now, what is the meaning of 3 duplicate acknowledgement? Duplicate acknowledgement means whenever it receives an acknowledgement with the same number, it's called as a duplicate acknowledgement. So multiplicative decrease, this congestion detection is also called as multiplicative decrease. Whatever may be the reason for retransmission, whenever there is a retransmission, it means congestion is being detected. And in that case, the size of the congestion window is reduced to 1/2 of the current window size. That is called as multiplicative decrease. So in that case, what happens is, so let's examine each of these 2 cases one by one. First is retransmission whenever a timer times out. If there is a retransmission because of a timer timeout, sender assumes that there is a strong possibility of congestion. So in that case, it's going to do 3 things. One is it's going to set the value of the congestion window. It's going to set the threshold to 1/2 of the current window size. Second is it's going to set the current congestion window to the size of 1 segment. Then it's going to start the slow start phase again. The second case is when 3 duplicate acknowledgements are received. If 3 duplicate acknowledgements are received, then sender assumes that there is a weaker possibility of congestion because 1 segment would have been lost and all other segments would have arrived out of order. In that case, that is called fast transmission and fast recovery. So in that case, TCP has a weaker reaction for this. Here also, the threshold is reduced to 1/2 of the current window size. And then it sets the congestion window to the size of the value of the threshold. In some TCP implementations, the congestion window is set to value of threshold plus 3 segment sizes, and then it restarts the congestion avoidance phase. Okay, so these are the two ways in which once a congestion is detected, how TCP is going to do congestion control. So I told you that it's going to wait for a retransmission. If 3 duplicate acknowledgements are received, TCP is going to retransmit the lost segment or the missing segment. So that is called fast retransmission. Here you can understand why it's going to wait for 3 duplicate acknowledgements. So here you can see that a sequence number of bytes with the sequence numbers 101 to 200 is being sent, and then it receives acknowledgement, and then it also again sends bytes with sequence numbers 201 to 300. Now, after receiving both these set of segments, the receiver sends acknowledgement 301, meaning that it is now expecting segments with sequence number 301. So once it receives, it also sends, next it sends bytes with sequence numbers 301 to 400, but this is being lost. Okay, the segment containing sequence numbers 301 to 400 is being lost. Now it has not received this, but next it sends segments with sequence numbers 401 to 500, 501 to 600, 601 to 700. But the receiver keeps on sending acknowledgement with the number 301 because it has not received the segment with the sequence numbers 301 with the sequence number which starts with 301. So it keeps on sending acknowledgement with sequence number 301. So once it receives 3 duplicate acknowledgements, here you can see that all this is first, second, and third. Once 3 duplicate acknowledgements are received, meaning totally it has received 4 acknowledgements, and once it receives, but this and this, all these 3 are, the last 3 are considered to be duplicate acknowledgements. Once it receives 3 duplicate acknowledgements, it understands that the segment with the sequence number 301 has not yet been received by the receiver, and it tries to resend only that segment with the sequence number 301 to 400. It will not resend this 401, 501 or 601 numbered segments. Okay. So then after receiving this, it tries to send an acknowledgement with the sequence number 701, meaning that it's now expecting a segment with sequence number 701 because it has received till sequence number 700. So this acts as a cumulative acknowledgement, and the sender is able to understand that all those segments till the sequence number 700 has been received well intact by the receiver. So they have arrived out of order, and all will be arranged in order, and then it will be sent to the application process in the receiver side. So this concept is called fast retransmission. Fast retransmission means whenever 3 duplicate acknowledgements are received, instead of waiting for the timer to time out and then do the retransmission, it immediately resends the missing or the lost segment, and that is called fast retransmission. So that is all about TCP congestion control. From this, you can understand that TCP congestion detection can be done in 2 ways. One is if the retransmission is by timeout, then it starts the slow start phase. And if the TCP retransmission is because of 3 duplicate acknowledgements, then it enters into the congestion avoidance phase. So this is the summary of the TCP congestion policy. First is the slow start phase, where it starts with congestion window size is 1 maximum segment size. This keeps on increasing exponentially until it reaches a value of slow start threshold. Once it reaches the slow start threshold, it reaches the congestion avoidance phase. And in the congestion avoidance phase, there is an additive increase in the value of the congestion window size. And then whenever the congestion is detected, it either sets the value of the congestion window to the size of the congestion threshold, that is the slow start threshold, or it sets the value of the congestion window to the size of 1 segment. And that is all about TCP congestion control. Thanks for watching. See you next time. Take care and bye-bye.